right, here we want to use Lagrange multipliers to find the absolute maximum and minimum between this here and this here. So this is 4 dimensions, w equals x, y, z, and this is 3 dimensions. So you wouldn't be able to graph this object right here because there's 4 variables, w, x, y, and z. F of x, y, and z would be w. But we want to find the max and minimum between the two. Well, we use this formula. It's really quite simple. All you have to do is take this part here and this equation here and just take the partial derivatives of this with respect to x, y, and z. Same with this piece here with respect to x, y, and z. And then slap a lambda in there times the g. And then set this function here is the same thing as this function here. All we do is bring this over to this side to be equal to 0 to be equal to g. And so that's all g of x, y, z is. You got to make sure you take this whole entire piece. Okay, so all you need to know is this, and write that down before you start solving the problem to get max credit on the test. And then take your partials. So 8, negative 9, 7, 8, negative 9, 7, 2x, 2y, 2z, bada bing, bada bing, bada bing. Write your g. Now you have a system of 4 equations with 4 unknown variables, lambda, x, y, and z. So now you can solve those. And in this case, what we're going to do is solve for x, y, and z in terms of lambda, plug it into this equation and solve for lambda. When we do that, we find that lambda is equal to plus or minus 1/2. Then we take that lambda and plug it back into the x, y, and z to find x, y, and z. Once we find x, y, and z, we take it back into the original function to find our values, plus or minus 194. It's pretty straightforward. It's kind of like a puzzle, really. All you got to do is get used to the puzzle. So if you want to pause this here, I'll let you pause it there if you want to look at it. They only give us 5 minutes to talk about this. I got to be quick about it. And then you can pause this part too and see that. And that's all you got. Thanks.